everyone. The three terms, isotopes, isobars, and isotones. Everybody is clear, right? Right. So once again, isotopes have same atomic number. They are atoms of same element but different mass number. Isobars have same mass number, right? Atomic number is different. They are different elements. And isotones have, they are atoms of different elements, different atomic number, different mass number, but same number of neutrons. So three very important terms all of you should know, along with some examples, and you should be able to identify if two atoms are given, whether they are isotopes, isobars, or isotones. Right? So fine, we move on to the next section. I think from this table you can identify, right, isotones you can identify easily from this table. Whenever you find same numbers, right, 10 10, 12 12, 14 14, these are all isotones. Okay, this row, number of neutrons same, right? Here you can find the isotopes, isobars, sorry. If in this column number of atomic mass number is same for two elements, those will be your isobars, right? And right, so okay, let's move on to the last part, laws of chemical combination, right? So first two laws, I think this you have studied before, law of conservation of mass and law of constant proportion, right? Just for revision, quick revision, what is law of conservation of mass? Anybody remembers? What is the law of conservation of mass? So basically mass can neither be created nor be destroyed. So in a chemical reaction, the total mass remains constant, right? If you are reacting to substances, let's say A and B, and their total weight is 50 grams, and if there is some reaction, after the reaction, the total weight will remain 50 grams. So total mass is conserved. In a closed container, if you're doing a reaction, you start with suppose 50 gram of some substance A and B. After reaction, suppose they convert to some substance C and D, the total mass will remain constant. It will remain 50 gram, whatever inside reaction may happen, right? If the container is closed, the total mass will remain the same. And what is law of constant proportion? Yes, what is the law of constant proportion? Law of constant. Anybody remembers what is the law of constant proportion? Second law, which is given here. So according to this law, see all names, in the names itself, the definition is given in all these laws. Okay. So constant proportion means elements are in fixed ratio. Okay. Elements, I'll write it differently. Constituent elements in a compound are in a fixed ratio, right? So if you take water for example, right? So it has 2 hydrogen and 1 oxygen, right? So there are two things, right? In whichever water you take, from whatever source you take it from a lake or river or sea, right? That water from wherever you take, it will have the same combination of elements. Two hydrogens and one oxygen will combine, right? So the ratio of the elements is fixed, right? It's always 2:1, right? Let's take one other example. NH3, if you take, it will have 3 hydrogen and 1 nitrogen. Always the ratio will be fixed. So if you take the ratio of the masses, that is also will be fixed, right? So here, if you take the mass ratio, hydrogen is to oxygen will be 2:16, right? This is the mass ratio. That is also fixed, right? If you take nitrogen is to hydrogen, that will be 14:3, right? So that is also fixed mass ratio, right? So this is a law of constant proportion. So from whichever, suppose ammonia, you prepare it in the lab or take it from somewhere else, the ratio will also always be fixed. Okay, here we'll focus on the next 3 laws. Okay, law of multiple proportions. So these definitions, all of you should remember. First of all, what is the law of multiple proportions, right? So again, if you focus on the name, you will get some clue. Okay, if you focus on the name of the law, you will get some clue about the definition, right? So multiple means there is some, so when 2 elements A and B combine to form more than one compound, means multiple compounds, right? That is the meaning of multiple here. So different masses of A which separately combine with a fixed mass of B are in simple ratio. So you fix one element and find the mass of the other element which it is combining with. Let's first understand this through an example. Okay, let's take this CO and CO2. Okay, so in CO there's 1 atom of carbon and 1 atom of oxygen, right? So 1 atom of carbon weighs 12, 1 atom of oxygen weighs 16, right? So the ratio is 12:16, right? That is the ratio. So we are fixing 12 here. Okay. Here also in CO2, carbon is 1 atom, so 12. And here 2 oxygens are combining, so total is 32. So if you fix this, okay, you fix one element and then focus on the other element. Okay. You fix one element and focus on the other and find the ratio. Okay. This ratio will be a simple number, right? 1:2, 1:3, like that. So this is the law of multiple proportion. That means elements are same. Okay, carbon and oxygen, both these compounds have the same elements. So 2 elements are combining to form more than one kind of compound, right? These are 2 different compounds. So these are forming 2 different compounds. You fix one element, okay, and find out the mass of the other element which it is combining with, okay, and take the ratio. That ratio will be a simple number. Okay, simple ratio. Okay, I'll take this example for your understanding. SO2 and SO3. Okay, so we'll take this law of multiple proportion. Okay, so let's take this example, SO2 and SO3, right? So you fix one element, right? Sulfur, here both have 1 atom of sulfur, you fixed. So what is the mass of sulfur? What is the mass of sulfur, atomic mass? It is 32, right? And oxygen, how much it is combining? 2 atom of oxygen is how much? 32. 3 atom of oxygen is 48, right? This is 2 oxygens, this is 3 oxygens, right? Each oxygen weighs 16. Atomic mass is 16. So you fix this and take the ratio, this ratio, which is 32 is to 48. How much is this ratio? What will be the simplest ratio? You divide by 16, right? You divide each by 16, you will get 2 is to 3. Okay, this is a simple ratio. Okay. What you have to do in law of multiple proportions, you fix one element, right? And it, what is the mass of the other element which is combining with the fixed mass of the other? So you have to fix this, right? It should be same in both, and then find the mass of the other element which it is combining with, and find the ratio of that. It will be a simple ratio. Okay, this is your law of multiple proportions, right? All of you are clear with law of multiple proportions, right? This definition you should remember. So when two elements A and B, right? We have taken example of like carbon and oxygen, sulfur and oxygen. That is the meaning of A and B, and they're forming more than one compound. So you fix one of the elements. It could be any one, right? See if it has the same number of atoms in both. You fix that and find the mass of the other which it is combining with, and you take the ratio. That ratio will be a simple ratio, right? Here it is 1 is to 2, here it is 2 is to 3, 1 is to 3, like that. Okay. Next is the law of reciprocal proportions. Again, if you focus on the word reciprocal, you will get some idea about the, right? So let's look at this example. So focus on the first three lines. If two different elements combine separately with the same weight of a third element, okay? So what are the two different elements? Here the different elements are hydrogen and oxygen, okay? These are two different elements, okay? They are combining with the same weight of a third element, which is carbon, okay? So two different elements. Hydrogen combines with carbon to form CH4, same weight 12. Okay, oxygen combines with carbon to form CO2. Okay, so both of them have one carbon, you can see, right? So that means they are hydrogen is combining with one carbon, that is 12. Oxygen is combining with one carbon, that has a weight of 12, right? So two different elements combining with the same weight of a third element. So this is your third element, right? Now you take the ratio of the masses in which they combine, right? So you take the, we will take the ratio of the masses in which they combine. So mass of this and mass of this, we will take ratio, and we will take the ratio. So these two can also combine, right? They are combining separately and they can also combine amongst themselves. Okay. So we'll take the ratio of these masses and take the ratio of the masses here, and we will see that will be a simple multiple. Okay, let me just write it here for better understanding. So we had what? We have hydrogen, we have oxygen, we have carbon, right? So carbon and hydrogen combine to form CH4, right? Carbon and oxygen combine to form CO2, right? So carbon is fixed, right? 12, 12. So 4 hydrogen means how much is the weight of 4 hydrogens? Each hydrogen weighs 4. 4 hydrogen weighs total 4. Oxygen, what is the weight? 16 into 2, which is 32. Okay. So you have fixed carbon. Okay. And then we take the weight of the other. So we get 4 and 32. Okay. So take this ratio. then you combine hydrogen and oxygen. Hydrogen and oxygen combine as H2O, right? Hydrogen is 2, total hydrogen is 2, oxygen is 16, right? So you take the ratio. What is the ratio? 2 is to 16, which is 1 is to 8, right? And you take this ratio. You take this ratio, 4 is to 32, which is how much? 1 is to 8, right? So this ratio will be same. Okay, here it is same, right? This ratios will be same or a simple multiple of each other, right? I hope it's not confusing. We will take one more example, right? So we are taking 3 elements. Okay, you take 2 elements which combine with a third element, right? So hydrogen and oxygen combine with a third element, and you fix the mass of that third element. Okay, and see what is the mass of the other element which it is combining with, right? You find the mass, take the ratio, and then combine these 2 elements with themselves, and then take the ratio. This ratio will be same or a simple multiple of each other. That is the law of reciprocal proportions. Okay, you can see here. I'll take one more example. Okay, same thing is mentioned here. Okay, so let's take. We don't have too much time today. So okay, how many of you are clear with this? Can you raise your hands? How many of you understood this law of reciprocal proportions? Okay, so I think not. Okay, most of you have raised their hands, not everyone. Okay, we will take okay, this maybe you can try it as homework. Maybe we can take it in the next class. Let's take this example which I've written here: hydrogen, sulfur, and oxygen. Hydrogen. So all of you note this down. You can try this at home. Okay. So these are the 2 elements combining, right? They form H2S, hydrogen and sulfur. Hydrogen and oxygen combine to form H2O, and sulfur and oxygen combine to form SO2. Okay. So you have 2 elements, okay, combining with a third, and they are also combining with each other. So you take it as a homework. Okay, prove the law of reciprocal proportions. Okay, take it as homework, and let's see if you're able to do. Maybe we'll take it in the next class. So you can look at the example in your textbook and try to prove the law of reciprocal. So just to give you a hint, right? So these 2 are the elements which are combining with a third element, right? Hydrogen. So right, you have to find the ratio to fix one element, find the ratio of the other elements, and also find the ratio when they combine with each other, and that compare those ratios. Okay, so try this out. We'll see in the next class. And there is one more law which we will see, right? This third law we'll cover in the next class along with this last one, right? So yes, I hope these 2 laws are clear: multiple proportions and reciprocal proportions. Okay. Okay, fine. That's it for today. We'll continue in the next class. Okay. Namaskaram. Bye bye.
Thank you.
Thank you. Thank you, everyone. Bye bye.